So this session is about native APIs and querying for Couchbase with Nickel. So Jeff Morris, our main developer of the .NET SDK. I'm Nitschinger. I'm doing the Java SDK. We are going to show you in the next 30 minutes or so how to query Nickel from both .NET and the Java SDK. Now, a quick disclaimer. Everything shown here is preview, like Nickel. So all this may change, or it will change to some degree. But so take everything with a grain of salt, and please, again, please provide feedback so we can make it better. We won't stabilize or finalize this until Nickel finishes and stabilizes. So there is enough time for feedback. Yes?
Does Nickel work today with, is it just like tutorial that it works?
So you can, how to put it, you can try it out in development. Yes, sorry. The question was if Nickel works today with the SDKs. The answer is yes and no. So you can use it right now, but you cannot use it for production. I mean, you can, but we won't provide support, anything like that. Nickel is in developer preview, and so is the support on the Java and .NET SDK for it. Okay, so it's evolving. Things may change. Things will change. You cannot use, or you shouldn't use it for production, because yeah. And also we won't support it right now. So as a quick introduction and motivation, so querying itself is very important for Couchbase Server because we are a document-oriented database. We want to provide you with facilities to query the data other than just lookups by the primary ID. And the SDKs currently provide two types of lookups. The first one is Fuse and the other one is Nickel. We won't cover Fuse today. This one is stable and ready to use since over here, and it all works fine. But Fuse have their shortcomings, as you may have learned already in the other Nickel sessions. Nickel provides you with different capabilities on how to query your data, especially ad hoc queries, more powerful queries, and so forth. So when we redesigned or developed the 2.0 SDKs, of course, we already had in mind how we are providing future support for Nickel. Now, and this is what came out of it. So again, Nickel is the next generation query language for Couchbase Server. It is designed by intent to be very similar to SQL. Personally, I see it as a superset of SQL. So it's like SQL, but with JSON support. And of course, there's first-class JSON support because that's what we are querying. It's currently developer preview. I think developer preview 3, 4 will be out very soon, and you can grab it over there. Now, Nickel supports selects, data manipulation language, and also data definition language. It's in the syntax, and this is defined. But for now, we are focusing on the select statement. That said, in the future, we are actively looking into provide other things like update statements, where you can do in-place updates of your JSON documents instead of replacing the whole thing. But that's in the future. Right now, we are actively working on support for the select statement, that you're fetching documents or data out of your buckets. Now, how does Nickel look like? This is a very quick primer on the select statement. So it is very similar to SQL. So you can select data, you can do counts, and the from here would be a bucket. So you would say from beer sample, from default, and so forth. And then you can use other things like unnest, which are there to work with nested JSON structures. So you can look into JSON documents, you can extract data out of it, you can populate it to another level, you can join them together and so forth. So this is why I'd call it a superset of SQL, because you can look into stuff and you can work with arrays and so forth. And then of course there are where clauses, group by and having, and then you can use order by, limit and offset, which makes pagination much easier as well. Now, we also support joins, we support inner, and so we support intra-document joins and extra-document joins. So you can join multiple documents together, or you can, in one document, you can join data from inside an array or an object outside and merge it with other data. So there are different capabilities there on that one. So we don't want to go into the Nickel language today because there were other sessions on that topic. But what we want to focus on is the 2.0 querying API. So our main focus when we designed it was to provide really consistent experience across both Fuse and Nickel, but also across all the different SDKs. So if you're doing a Fuse query, a Nickel query from the Java SDK, it should feel very natural if you develop another application in .NET. It should feel the same to do this. But also, we want to, again, focus on language features. So with .NET, as you'll see in a minute, there is stuff like Linq, which is just not available in Java. So of course, in .NET, we want to provide support for that because that's the natural way to do it in .NET. In Java, we are providing a DSL, which is syntax aware, which I'll show a little later. So with that, I'm turning over to Jeff, who is going to introduce you to the Nickel querying with .NET.
Thanks, Michael. Hey everyone, how are you guys doing today? So .NET or Nickel support in the .NET SDK. In the .NET SDK, we're talking about a couple of things. We're talking about query generators and query executors. We're also talking about mapping results and handling errors. When you're talking about query generators and executors, we have two main ways of interacting with Couchbase Server using Nickel. One is support for ad hoc queries, and the second way is through an in-development LinkProvider. So Linq, if you're not aware of it, Linq is a language integrated query. So it's a kind of a syntax built into the CLR family of languages that allows you to query data stores in a kind of a SQL-like manner. And what it brings is a familiarity across multiple persistent stores. So if you're querying, like, say, an object collection, querying or a SQL database, or even querying Couchbase, the syntax you use is very similar. We'll also talk a little bit about mapping results and handling errors. And it's really important. The SDKs themselves handle the relational mapping between a result and like a standard POCO or a plain old CLR object. In Java, you call it POJO. And also query results, which is kind of like a rich, it's an object that when you make a query, you want to get something back. What you get back is actually a query result. And that query result is a rich object that gives you information about the actual query that you performed. So it'll give you, if it performed successfully, it'll give you an indication that it was successful. If it failed, it'll give you a reason why. So ad hoc queries are the first kind of integration we put on in the .NET SDK. They're part of the SDK 2.0 iBucket interface. Really, what they are is just a standard string that you're passing into and getting into the API, and it's going to execute it and return back results. So it's very easy, quick and easy to get up and running with. Unfortunately, it doesn't have things like syntactical help to kind of help you generate your query. Results are mapped to POCOs. So POCOs are plain old CLR objects. So in other words, just a domain object or an entity. Or even better, to a dynamic type. And a dynamic type, if you're not aware, so .NET has a concept of a dynamic type, which is a statically typed object that at compile time, the static checking is turned off and it's only enabled at runtime. So what happens is you kind of have this late binding kind of concept, which makes it really easy to work with JSON as long as you get the JSON, the actual structure correct, the element names correct in your JSON. So the cool thing also is with ad hoc queries, we immediately get support for basically all Nickel commands. So all that are available, you can immediately execute them against the bucket. You also get, your handles are propagated to the caller. It's important. So like I said, you get this rich object back that describes kind of what the state of the query was when it was. So the query executes, and it gives you kind of an idea of what actually happened, whether or not it succeeded or failed. And we also, it is the query interface for .NET using Couchbase Server for Nickel queries. So here's here's a basic, here's an ad hoc example of an ad hoc query. So at the top here, we have a query, a const string query that we defined. It's a select statement. We're going to take fname, email, and children from tutorial, and where the length of children is greater than 0, and email it's a wildcard character. So any Gmail, any email that's like that is a Gmail account. We're gonna open a bucket from the cluster. Then we're gonna query that. We're gonna query the object. We're gonna execute the query, and we're gonna execute the query, and we're gonna type it to a dynamic type. Excuse me. Then we're gonna iterate through the results. So the result object, we'll talk a little bit about that in a minute, but the result object has a rows collection that's part of it, a property that's part of it. That properties is actually your result, and it'll be typed to a dynamic type. If you change the dynamic type to say like beer, or in this case children, that would work, children, and you had to type defined as children, you'd get back, you'd be able to say, row dot fname, row dot email, etc. So here's the actual iQuery result object. And what you see here is we have the query result object, that's the main return value. And then you have properties defined on that. You have an exception property if an exception occurred, a message indicating what failed or what didn't fail, or actually it's really just what failed. And then a Boolean property success, whether or not the actual query is successfully completed. So you could really easily, it's easy for you to say, execute a query, get it back, and say, if query.success, handle the code this way. Otherwise, it failed, do some kind of failure, indication of failure to the user. Oh. So, sorry guys, I went up a little too far ahead. So right here we have, on the other side, we also have a error. So this error property is, it's a class actually, and this class returns back basically everything that the Nickel engine generated if there was an error. So it'll give you back details about what actually failed. Then on the other hand, which is the rows, which is just a list of T, generically typed to T. So how do you handle errors? I kind of just mentioned this. Is you get back this result object, and you're able to check it for results, or for errors, excuse me. What's cool is, so here's an example. I have an untyped query, and in this query, I've misspelled the length function. So length is a built-in function in Nickel, and I've misspelt it. So there's nothing at compile time that's going to tell you this is going to fail. You have to wait till runtime. Well, at runtime, as you iterate through, the results will actually return back the result. The query will execute. It will turn back the iResult object, and that object will kind of tell you, give you an indication of what failed. In this case, no system function name LENGT registered. So Nickel is actually telling you, hey, look, you have a semantic error, and this is the reason why. Very easy to fix. So another important part of the SDK is actually mapping result sets, which is just raw JSON, to types. And there's a built-in object mapper within the API. You get your results back. They'll be typed to whatever you specify as T. Like I said, it could be an entity object, like a plain old CR object. It could be a dynamic type. It could be a string if you just want the JSON back as a string. So we have the ad hoc support for querying Nickel, which is really cool, but it lacks some things. And what it really lacks is kind of this consistency in the .NET world. right? So in the .NET world, when you're talking about any kind of interaction with a database, you're almost always talking Linq. Linq is one of the I guess, the success stories of .NET. So what we were starting to develop is we began to develop a LinkProvider. It's an extension of the actual API. So in other words, the SDK is at one level, and the LinkProvider is another layer on top of it. The two are actually going to be packaged separately, but they'll work together seamlessly. It's an open source project. Pull requests are gladly accepted. It's available on GitHub. Currently, it supports a minimal subset of NCL and the NCL language, but this will change soon as we start adding more and more features. If a feature isn't supported, it'll actually return back an error saying a not implemented exception, because it kind of gives you an idea. In that case, if the feature isn't supported, you always have a fallback, and that fallback is your ad hoc querying. Errors are unhandled. So what I mean by that is it doesn't actually return back an I result. It actually returns back an I enumerable, and that I enumerable is what you would use to iterate through and display your results. Results are mapped to POCOs. This is really, I believe, is the future of NCL querying in .NET. And I think there's going to be we're going to put a lot of effort into this in the next several months to make it really a strong, a strong API for querying Couchbase Server. Here's an example. Sorry. So here's an example. So I'm going to open up a Couchbase cluster. If you notice, it's very similar to the Java SDK. The syntax very similar, naming conventions, etc. We're going to open a bucket. In this case, it'll be the beer sample. And then what we're going to do is we're going to build a query. From B in bucket queryable beer, select B. So what that's going to do is literally go through and pick every document that's in the beer sample bucket, and it's going to convert the result set to a beer object. And then I'm going to iterate through at the bottom. We're iterating through and just displaying the name. So here's another example, progressions to anonymous types. So in that case, that's a progression, in that case, you're iterating through and you're converting to a POCO. In this case, we're doing a projection to an anonymous type. So very similar to the last slide. So we're opening the cluster, we're opening a bucket, and then we're going to generate a query from B in bucket I.queryable beer. Select new name.b.name, ABV equal to b.abv. So what this is going to do is going to create a dynamic, or it's going to create a subset of the beer as an anonymous type, and then you can go through and iterate through there. Like all link operations, the operations are deferred, so this actually won't run until you iterate through it. So right about here, it'll actually go through, create the NCL query, and execute it against the database, or the bucket. And here's another example. This example is going to show, it's very similar, the same as the last one. The difference is there's a where clause in there. From B in bucket.queryable beer, we are getting a b.type equal to beer. So it's going to get all documents that are a type of beer. And then it's going to do another anonymous projection here. And then we're going to iterate through that projection. And here's another example. This is an example of, so if you're going to do like pagination, where you want to paginate through a list of documents. So you had 100 documents or 1,000 documents, and you only want to show 10 of them. Here's an example. In this case, there's the query, and then take 10, skip 5, and then iterate through it. So future support. So the future is really hard to predict, turns out. But expect a GA release when NCL GA is released. That's kind of our goal. Eventually, it will be a full-fledged provider. Initially, it's going to start off as small. We're going to implement smaller feature sets per iteration. Anything that's not supported by Link can be done through iBucket.query and just passing in a string of a nickel string. So with that, I'm going to do a quick demo. So the question earlier was can you use nickel today with Couchbase? And the answer is yes. You just don't want to do it in production. And this is actually an example. And this example right here, which you can't see, sorry about that. Okay, guys, sorry about that. This is going to be a little, this is going to be hard. Okay, so bear with me here. Okay, so here we go. We have, here's a simple application. What it's going to do is I'm going to run a link query. It's the same code you saw on the slides, essentially. It's going to run a link query against the beer bucket, I like that. It's going to run a link query against the beer bucket of a Couchbase server running locally on my machine. It's going to get the results, and then it's going to emit, it's going to get the results, and then it's going to write the result out to the standard output. It's so hard, sorry guys. And yeah. And there we go right there. Sorry guys. And hopefully you can see that. So what it did is it went through each document in that bucket. It pulled out the name and the alcohol by volume. And it basically says beer name has X number of alcohol by volume. And that is running against Couchbase server, running locally on machine. Okay, with that, I'm going to hand it back to Michael.
Thanks, Jeff. So, let's quickly go through how nickel querying in Java works. Now, in Java, we do not have such nice things as link, but I tried hard to give you a nice experience as well. So, with the Java SDK, you can access it both asynchronous and synchronous, as you may have guessed already, with Rx observables. So in the core package, we are utilizing a JSON streaming parser that just takes out the chunks and streams it to the user as they come along. And it works on a per bucket basis. Now, how does it look like, the result of a query here? And this is the synchronous API. So there is a method called all rows and rows. Now, the main difference is if you call all rows, it will internally batch it up into a list and return you the list. So this is only a convenience accessor if you only expect a few rows, like 5 or 6 or something. But if you are streaming a lot of data potentially, you want to use the rows method, which gives you back an iterator, where you can pull data out of the iterator as it arrives. And then there is also an info method, which returns you the information that gets returned from the server, as well as a Boolean success flag, and optionally the error method will be populated if an error happens during the nickel query. Now, a query row only returns the value of a JSON object because very different to a view response. A view response has a key, document ID, and a value potentially. With nickel, because it can return anything, you just get access to the raw JSON object value. Now, how does it look like with an ad-hoc query right away with a string? So there we go. There is the bucket.query method, and this is a synchronous call. We get the query result once this is done. And if the result is a success, we grab the iterator, and while the iterator has rows that we can pull out, we grab the next row and just print out the value. So that's basically very basic synchronous access as you would expect for synchronous querying. Now, yeah, and this is the all rows shortcut. So if you just want to grab the full list of rows that got returned, you can just use all rows, get the list, but keep in mind that if you are querying potentially a large set of data, this is probably not the best method to use right away. Now, of course, we also support asynchronous querying. So here we're using the synchronous bucket we call async to get access to the underlying asynchronous API. We call the same method, and then we use the same approach with the views. For those of you who have been here in the previous session, we can use flatmap to get the rows out of the returned result. And then we use the map function to just take the value out of the row object, and then we just print out the value. So this is the exact same one, but completely asynchronous. So because we do not have Link, I was looking around trying to find the best way to access SQL-like data. And one project stood out. For those who know, it's called Joke. And it's a very, very nice way to query SQL-type libraries, SQL data stores. Now, what they have implemented is a very nice syntax-aware DSL, which knows where you are in the code path and only provides you those methods that you can actually do as part of your syntax. Now, I shamelessly copied that approach, but with Nickel it's much simpler because Joke has support for all different SQL data stores, Oracle, MySQL, and so forth. With Nickel it's much simpler because we can focus on one API only. And what we got from that is something like this. So this is from IntelliJ. If you call select, and select is a static import, and then you type dot, what you get is all possible methods that are possible in a Nickel query. So this is built based on an interface hierarchy. So there is not a fancy module or plugin that you need to install in your IDE. It just works right away because it's just based on methods and interface hierarchies. So if you call select, you can do select from, but you also see that you can do group by, inner join, inner nest, join, left join, and so forth. Now, if we go forward, let's say we already did select a first name from users. The joins are gone because that's actually not valid Nickel code anymore, syntax. So when we are here, you can see we can do where, we can do union, to union with another select, and so forth. So and as we go forward, finally at the end, if we apply a limit, the only thing we can do is an offset because this is the last part of a Nickel query. Of course, you can omit it. You could say just select from and that's it. Under the covers, this will generate a Nickel string and pass it on to the server. So here are some examples. We also provide shortcuts for Nickel expressions. So if you do the X static import, you can do things like X, H, S, H-dog years, and this will render you other parts like first name equals Dave and so forth. It will automatically, if you use the S import, it will automatically provide string type capabilities for you. So there are a few helper methods which you can use to very elegantly build type-safe Nickel queries with the new Java SDK. Here's another example. So we can use select from where, and there you can see there is the length method. And in the .NET example, we saw that Nickel returns us an error if we misspelled the function. Here we cannot even misspell it because length is actually it's part, and it would fail on compile time if you didn't get the method right. So we will provide more and more functions. We currently only provide a few, but we will add more and more. When Nickel gets G8, this should be the fully fledged DSL available to make it really easy for you to build type-safe Nickel queries. So I think we are right on time. Unfortunately, I don't think we have time anymore for the Java demo. If you're interested in that, come over here and I'll demo it to you. Are there any questions? Yes, one?
When you query
So the question was if there is an equivalent for stale and non-stale data. So currently there is no equivalent for that. I think we need to wait until Nickel matures in that regard, what options are provided from the server side, and then we'll probably, of course, integrate it as well into the DSL there. Currently, there is no such option. That's a good question. So by default, the developer previews use views underneath, which has update after as the default. But once it gets integrated into the server product, it's a completely different implementation for secondary indexes. So semantics will be different over there. I'm not, to be honest, I'm not 100% sure how that's going to work out. But of course, there will be options available as well because you need it in a production system.